I'm Mike Peterson, and I'm here joined by Andre, and we're going to talk about some platform engineering stuff. I'm going to ask a couple of questions and see what insights Andre has, and then we'll hop into it. All right. So, who are you? What is your role, and how does it apply to platform engineering?
Oh, thanks, Mike. Yeah, my name is Andre Marcelo Tanner. I'm a staff DevOps engineer here at Ada Support based in Toronto, Canada. What we do in regards to platform engineering, really on our team, we're a small but mighty team of infrastructure/platform engineers. And the way we've been able to scale our platform for developers on Kubernetes and other technologies is to really think about how to make everything we do as self-service as possible and do everything with product or platform thinking in mind. And that has allowed us to go from being support ticket operator type folks to be more product driven, creating based on what our developer users need, and then giving them tools so they can go and solve that themselves. We still do have operational work on our team. From time to time, you always got to upgrade that Kubernetes cluster, but everything else, when we see the value at scale when we make these platform tools on our team.
So, Andre, what is platform engineering to you?
Yeah, Mike, thanks for that question. Platform engineering to me is doing the work, abstracting the work away from others and making it easy to use. Really along the lines of how the team topologies book describes it, where there are stream-aligned teams and there are platform teams. And really, you look for the work in the company that everybody's doing, but that they're all doing repeatedly in different ways. And you look for those places where you can optimize and bring about a common pattern. So really, yeah, that's really what I see. Like we've been doing platform engineering as a industry for years before Kubernetes existed, before configuration tools. A developer saw a problem and said, oh, 10 people are solving this 10 different ways. Let's just have that one standard and let's go on to solve other problems. Let's not do this every time, and a platform gets born, right? And you see this in all kinds of companies where they have their different internal platforms. Google Board was one such platform, and you have others at bigger companies like Amazon, Facebook. They have their own, and then smaller companies now you're seeing there's a proliferation of tools out there like the CNCF ecosystem, and folks are wondering, how do I adopt all of this? It's so much. But when you have your engineers thinking as platform, you think well, you don't have to adopt every one of them. You just find a way to thread the needle and make something that works for your organization, or take a ready to go platform. There are a ton of solutions out there, and just go with that. So yeah, in a nutshell, it's abstracting the complexity of the world around us. It used to be much simpler. We just upload some files on an FTP server, and there's your website. Now it's the front end is its own platform, the back end is its own platform, the infrastructure. There's so much, everything is so much more powerful nowadays. But with that, that power comes complexity, and we only have so much we can fit into our brains of and companies want to go faster, move faster, right? And so I don't know, maybe we'll see a platform shift to AI platforms where you can do more plus all these things that do it for you.
So basically, you touched on some of this previously, but what's the hardest part about building platforms? You're talking about different tools and stuff like that too. What's the hardest part that goes into it? Are you taking requirements from developers? Are you taking inspiration from the community? What do you do when you're building a platform?
For us, being I think most platform teams you find only get there when you have a large enough organization or a large enough set of problems that there's actually some value in abstracting that. If you have 5 developers, they might as well just write a guidebook and copy paste all their commands. There's no point of them making a platform for 5 people. But when you have 20, maybe you'll get one platform person. When you have 100, you'll maybe have a small team, which sometimes is the DevOps or operations team, just hey, you guys do everything. Can you please abstract all of this and do some common things? That's how you get platform teams. But I think that the hardest part is not the technology, although it's the most interesting part. It's stuff we love to do as engineers. The hardest part is actually finding what you shouldn't turn into a platform, what you shouldn't abstract. And that's very hard to do because we love solving problems. For example, I'm doing this monotonous thing that I just need to do one time, but it's taking me an hour today, and maybe I could have written a script for this, but I'm only going to do this today and probably not in the next 6 months. So should I write an automation for that? Should I abstract it away? Honestly, probably not. It could probably take me longer to write the abstraction than to actually do the hard work, right? And with AI tools nowadays, the hard work can actually be done faster, right? So
You're saying it takes discipline.
yeah,
It
you
takes
gotta find
discipline to
the
not. Yeah.
yeah, it takes discipline. You gotta find the right balance because building any platform means you abstract some of the complexity away, but then your team has to hide that behind some interface, behind some UI, GUI, API, and so you're taking on that complexity for others, for developers, but then you have to maintain that. So, for example, you could give all your developers Kubernetes and say, "Hey, learn all the Kubernetes YAML. There's a deployment service, HPA, Istio, Linkerd, Argo CD," and then they're like, "We have a job to do. We can't learn Kubernetes just to do our job." So then you have to choose how to abstract it and how much to abstract of it to simplify it, right? And I think that's the balance there, where it's really finding the what not to do, what to do, and what not to do, and doing what gives the most value for your users or for the business. So it could be awesome if you'd make this awesome system and all your developers would be happy, but like, would that be valuable to the business of how much it costs to make or maintain? And yeah, at the end of the day, I think it's like the business and the human problems are the hardest parts. Because also at the end of the day, like you make it all, everybody's bought in, like the business gives you the time and money to invest in it, and then nobody uses it. Oh, why? Because maybe you didn't find out if the humans are really going to use it, right? The people. So
You're saying like
that's
communication's a big part of it too, right? Communication and being able to like document things and then interact with people.
yeah, or even just getting users. So I think it's sort of like how they say it's like you're running your own product or startup within a company. You have to get early adopters, get them to use it, get them to come back, fix them, and then like if they drop off, then find out why. And so we've seen heard these stories before, but yeah, that's the hardest part is like, no, yeah, choosing what to do.
So what would you recommend as a career path for someone who wants to get into, building platforms and on platform engineering teams?
So I started out as a web developer back when the term was webmaster, doing HTML and PHP, and the thing was like just there was no like back end front end. It was just like upload your file via FTP, then SFTP, and then other ways. Like there was operations. There was server people who would like go into the DC data center and like reset the cabinet or KVM something. But then as everything went to the cloud, like the developers got more ability to do all of that, and so I was able to learn all the server side, and sort of that led me to like DevOps and infrastructure just from being like a back end front end developer. And so I think a good career path of getting into this is where you find your place. You find yourself automating a lot of these tools, these common workflows, and you want to make it easier not just for yourself, but it's great if you optimize your workflows. So knowing the developer problems and how they do things is a really great place to start, and be able to say, oh, I can abstract this and make the entire company faster, make all the front end developers faster because we made this tooling, we made this abstraction, we made this platform for those developers. Or you can do it on the back end and make them faster, and then you end up like abstracting Docker files, abstracting workflows, CI pipelines, and then maybe abstract the infrastructure. So sometimes folks come over from the ops side and then become developers, but I think having the experience on both sides makes for really good platform engineers because they see the complexity of the operations and the things behind the hardware and the reliability side, but they also see like the need for speed and developer productivity on the developer side. Yeah, so I think either folks, but I've seen really good people come from the developer side, and then when they get the urge to just abstract things away, and then they see all the complexities on infrastructure, they're like, why is it so hard on the infrastructure side to do stuff? And they just want to code over it. And that's great because then you can do so much with software.
Would you call yourself a generalist or a specialist, do you think?
I'd say more of like a T-shaped generalist. Really the deep dive right now is Kubernetes, but I can do front end, back end if I have to. Even nowadays, I think with the advent of AI coding tools, there's very like little like excuse to like not code as a operations person or a DevOps person, because you can just sort of like type it in and say, oh, make me a Python script that does this and that, and then like it'll generate and you check it and verify, right? Versus before you had to like know the language deeply or know different languages and be able to support all your developers in those languages. But now like it should be easier to do more platform things. Sorry to add the AI thing, because we use a lot of AI
That's fine.
tools
Yeah, yeah.
in our company today, and like it opens up a lot more doors for us, no matter like what part of the engineering org we're in.
What are some of the tools that you would recommend, to build platforms? I know we're kind of in the Kubernetes, CNCF space. Like, do you have any specific tools that like make it easier for you or that you would recommend?
Yeah, so this is where I say to most folks, use what you have right now and don't just go for the latest and greatest, because there will always be something new. So if your company has been around 10 years, you probably have maybe systems that have been around 10 years, Bash scripts, Puppet, I don't know, Ansible. Like use that to start, but just have whatever tools you use, just have a standard. Like don't use two different tools to do the same thing or three different tools to do the same thing. Just pick one. Because once you standardize, like say if you standardize everything on one CI pipeline, then when you say, oh, there's a better CI pipeline in the CNCF, or you can use Argo workflows or whatever, GitHub Actions or something, it's easier to migrate everything over because there's a one-to-one. And so even during a migration from one tool to another, you can build that platform, or you can start building that platform in where everything just gets migrated, because all the migration can be handled by an abstraction or an automation by one team versus every team having to go in manually and migrate. But personally, our team, we're using Kubernetes since 7 years ago. So we've been Kubernetes native. We've also gone off to like cloud specific things like Lambda and come back. But we really found the most value in standardizing. Like at one point we had 2 to 3 different CI providers. Now it's just one. So we can abstract away, like we've abstracted our deployment pipelines using GitHub Actions and Argo CD. And sort of maybe here's a good example of platform where our developers use Argo CD, but they actually don't touch Argo CD manifest at all, because our team made custom like workflows or GitHub Actions that abstract away the Argo CD. So all they do is merge their branch in, our workflow runs, creates the necessary Argo CD manifest and deploys it. And the developers just use Argo CD as a UI to see, oh, it's on Kubernetes. It's all working. So that's like a platform abstraction that we've done there, versus having to have them like understand what Argo CD YAML does, what all the fields mean. Like it's the same for every single service, or we have to standardize. So yeah, and I think like as we see new tools come out, we find ways of how to adopt them, because once we like create one abstraction here, we can sort of like start piecing things together. And I know you have some kind of like, you have platform, what are they called? Platform frameworks nowadays, sort of like Kratix, that have come along that let you like plug things in together and maybe backstage. So we sort of, for now, we've built our own abstraction layer. And so when we see like a tool like, what's a good example? Maybe some observability, like from, well, we use Datadog, or some, what's something we're looking at? So example recently is where we've had to migrate to a second cloud provider and spin up everything from there. And so because we already have our abstractions in place for doing, say, service roles and OIDC on our first cloud provider, we can just extend that abstraction and make it work for the second cloud provider. And so the services just deploy and work automatically across clouds without having to like get individual authentication for each service. So that's one really neat thing. Another thing is like we changed secret management tools from a more, say, sealed secrets type you could submit in your repo, versus to another, like we're actually using Doppler, but it's a vendor solution. But we were able to do that because we had the abstraction platform over our services, so we could migrate everybody easily, and they didn't really have to do much work. So it really makes a lot of toil easier. But yeah, we like the CNCF ecosystem, I think, the most, because there's a lot of support out there, and there's lots of folks who can say what they've done, what works well for them or what hasn't worked. But still, we pick and choose and try to like use the same things in different parts of our stack.
Do you have any additional insights or anything you'd like to provide before we head out today?
Yeah, I'd say it's good to keep up to date on what others are doing, so you can learn how others are building their platforms at their companies. I think like 10 years ago, this was very much every company had a different solution. They didn't talk about it much, but now we have like platform day at KubeCon all the time, and there are so many talks there. So it's very much like everybody's now standardizing on the same patterns. And so it's good to watch those KubeCon talks and see how folks are solving problems. Maybe you've solved it a different way and you can talk to them about it, or you'll learn something from those talks. Also follow the folks in the space like you and the people in the CNCF platform working group. The CNCF Slack group is a great place. There's a working group platform channel where the folks meet every 2 weeks and they just talk about these issues. And so you find a lot of like common problems and see how they're solved. Like you find even like from startups all the way up to like big banks of how they're solving these platform problems. And they're all not necessarily doing it the same way, but you see similarities in the themes. I think that's a great way to find where to start, or like how to get yourself unstuck if you don't know where to start in this platform journey.
Well, thank you so much for joining us, Andre, and thanks for your insights and your stories and everything. I think people will really, connect with it and enjoy it. So
thanks, Mike. Appreciate the questions very much. It's great being here.